Hello viewers, once again welcome back to Java Jagran. Uh, as part of collection video series, uh, today I am going to talk about the internals of linked list. So in my previous video, I have discussed about the how the linked list, what are the important method in the linked list available, and how to work with all the that important method of the linked list. So as part of this video, I am going to talk about the all the internals, how the all whatever the method I discussed in the previous video, how those all those all methods are working internally. So I'm going to talk about that. So let's just start with that. So the apart as like you people have seen in the vector and the array list, those internally perform the store the data in the form of the follow the algorithm data structure called global array algorithm. But the linked list is little different from the vector and array list. It's not storing the data in the form of array, and it's not follow the data structure called global array. Actually, it's internally follow a data structure called linked list. You people have in the DS, you have people have learned like singly linked list, doubly linked list, circular linked list. So same like that, our Java linked list is internally following a doubly linked list. So for that, how it's follow like if we will go and see internally, it's having one class called node. Internally, it's created one inner class inside the linked list with a name called node, and it's used to store the all the data in this one. So it used to use this class. It's having the one object class item. So whatever the data you will put into the linked list, for adding that will stored into the item. Along with that, in the node, one having the next and one having the previous address. So next will be store the address of the next node, and previous will store the address of the previous node. So for this, so totally in the node class there is the three attribute is there. One is the object class element in item, and after that same node class attribute next, and node class attribute previous. So it will store in this. So if you will see in the pictorial picture notation, so in the pictorial notation I can show you like that. It will be storing like this. Whenever it will we add any data into the linked list, it will create one object of node class that will be look like this in a pictorial notation, and it will in the previous, it will store the previous class previous node address, uh, previous object reference, and the next it will store the next object reference, and in the place of element it will store the data whatever object you are passing to the linked list for the adding into the linked list. So this is how it's works. So let's start with the understanding each and every method of the linked list from the starting. So for that, I'm going to start with the add. So whenever we will create the object of the linked list, and we will call a method add. Suppose here I'm created one object of the linked list called list. That is the reference. On that I'm calling the add method with passing the one object. Here I'm passing the string object called ram. So if you will pass this one, what it will linked list internally will do, add method will do. It will simply create the one object of the node class. In that, on the previous it will store the null, and the next it will store the null initially, and that whatever the object we passed, it will create one object for that. We already passing that object. So what it will do, it will just start referring that object from the this element one. So in the previous slide we saw like that, it storing the three, having the three attribute called previous, next, and the element. So previous will be null, next will be null, and the element will be containing that object. And the linked list is internally having created a node that will be pointing to this node. So it's actually it's a first node. That's why this one will be pointed by the linked list node. And the same like whenever we call the, again we will call add method. Suppose we are again calling add method with another object called stamp. So whenever we will call, what it will do, it will just create one more object of the node class, and it will add into the next to this existing node. So simply if you are calling the add method, what it will do, it will simply go and add the object into the last. where what how many the node is already available, it will start reviewing from first. It will start the searching from the first, and it will, so it will first, it will having the address of this object, so it will get this object. Then it will search like that. If it's the next node address, it's having the next node attribute. If the next attribute is not null, then it will go to the next attribute. If that one is also not null, it will go to the next attribute. Like that it will travel. And wherever it will found the null, so if you will see the previously, it's here it's found the null. So what it will do, it will create one object of the node class, and in this next it will store the reference of that object. So this is how it will store the object. So same like when we will call the add method with double parameters, so we can add a object at a specific location also. So whenever we go to add the object at a specific location, so how it will work, like it will start traveling from the first, and it will keep on counter that will be counting from the how many object we traveled. After that it will suppose here we are saying that add to the first location, so it will go to the first location, and at the first location it will create the one object with this one. Suppose we are passing the node, so it will create one object with this one, and using that object it will create one node. And the node item place, it will add that object. In the next it will add the previous node. Suppose we are calling to add at first place, so what it will do, in it will create one new node, and on that node, on the previous location, it will add the zero index node next. And in the next it will add the second index previous. So it will link like this with the previous node and the next node. So now it will become the one list. So this is how the in the middle it got acted. So same like the if you are calling the add first, so add first also will do what it will do, it will go into the beginning, and from the beginning it will add the whatever the data. And the beginning, the starting node, the previous had the null, so it will they started pointing to the this one. And now the linked list will be pointing to this John object node. So this one how it will work. And the add last, same like the add also, it will go and add it to the last. So actually if you will see the internal implementation of the add method, so add method is nothing but it's internally will be calling to the add last. So Java will not return the logic twice into the both method. It's just return the logic into the add last, and from the add method also is calling the add last, because any of both the method are working same. Both the method will add the element into the last only. So this is how the add methods are working into the link. Now if you will come to the next method, next we are going to discover the get method. So how the get will work, the get method, in the get method there is one get method with the index and one get method with the object. So first we will discussing on the get with our index. So suppose here we having the linked list with the reference called list. On that linked list we are calling the get of one. So how it will get it, it will start from the beginning. Suppose it will take the first node, because it's having the only it will containing the address of the first node. So from the first node it will look at that. If the next is not null, it will go to the next, and along with that it will keep how many times it will go to the next, it will keep the one counter, and it will get increasing, and it will compare with this past value 1. So it will compare come to here. Here the node is 0, so here the counter will be 0. It will search to the next, it will go to the next object, and here counter will become the 1. So if the whatever the value we are looking for, whatever the index value we are looking for, and the counter will be become the same. So from there it will take the item value, and the whatever the item object is there, that will be getting returned. So this is how it will return the node. So same like if you will calling the get first method. So get first method, what how it will do, it will go and it will take the first object, and it will simply return the first object. It will go to the first node and it will return the first object, and it will be returned. Same like get last will also, it will start traveling from the file. Actually, if you will see the linked list internal for the better performance is storing the two address. One will be storing the first node and one will be storing the last node. So whenever we need to get the data from the beginning and the last, if we are calling to get the data from the last or add the data into the last, so no need to travel from the beginning till the end. Suppose 100 data already added, so what it had to do, it had to travel the 100 node, then it will reach to last. So for that, what linked list people did is they stored the last node address also. So whenever any operation you have to do into the last, so it is using the last reference. Whenever it had to do the operation from the first, so it will be adding into the first object. So like that, it will go into the last, and the last object will be returned. So this is how it will work. So yeah, now next we are coming to the remove method. So how the remove method will work? Suppose a remove method is having the two method, like one remove with the index and one remove with the object. So remove with the index, how it will be working, like same like a gate, it will start traveling from the first. Wherever the index will get matched with the counter, what it will do, it will interlink the previous and next node. Suppose here the first is there, so it came to the first node, and here what it did, it's go to the previous node, and previous node it's linked with the next one, and the next node it's linked with the previous one, because it's following the doubly linked list. And this is how the middle object, whatever the object is there, it got deleted, because this is now pointing to this one, this is pointing to this one. So anyhow, if you will get it traveling from here, we will get the next, so it will jump to the this one. So anyhow, the middle object that does not have any existence, so middle node will get deleted. And the same, like if we will call the remove with the object, so it will same, it will start from the beginning, and it will start looking for that object. It will start comparing this object with the item only. It will start calling the equal method. Wherever the equal method will return true, it will be simply what it will do, simply it will interlink the previous node to the next node. And this is how the middle node will do, whatever the object we call for the remove, it will get removed. The same, like if you will call the remove first, it will go simply go to the first node, and it will stop the pointing to the first node, and it will start pointing to the next node. So this is how the first node will get removed. Same like if you will call the remove last also will be start pointing to its just one step previous one, and this is how will the last node will get removed. So this is the about the remove method. Now next is the index of, for the searching, we can do the search operation also in the link. For the searching, suppose we have one object and we want to just know the index at wherever it's available. So for this also, it will start searching from the beginning wherever it and for the each and every node, it will with the item object, it will call the equal method. So first it will call this one with equal, so it will be return false. If it will return false, it will go to the next node by calling the next using the next address. If the next is returning the true, what it will do, it will simply while traveling, it will keep the increasing the counter also, and wherever it will equal method will return true, it will be returning that counter. If the equal method is not found till the last and we got the null into the next, it will returning the -1. So this is how the index of method will work. And the next is the last index of. So last index of, how it works, the index of will start searching from the beginning. Instead of that, last index of will start searching from the last. So from the last, it will start searching till the beginning. So how it will, from the last, it will be calling the previous node, previous node, previous node, and each and every node, it will be calling the equal method. So wherever the equal method will return true, it will be returning that index number. Else it will be returning a -1. If we will reach till the first and it didn't found any equal method returning true, then it will simply return the -1. So same like contains method also. So if we will pass the suppose we will say like the Syam content. So contents will start searching from the beginning, and it will start calling the equals method, and wherever on which node it will call the equal method will return true, it will simply return true. Else If it's reached to the last till the last and it's found the last node and next node as null, it will be returning as a false. So this is the how the index of searching methods are work. So that's all in the internals of linked list. Hope you people have get benefited with this one, and if you have any doubt you can comment on the video. You can also comment contact me on using Facebook also. Facebook also we have the same page like Java Java and we are maintaining. So keep watching the video. Meanwhile, have comment and subscribe. Thank you.